Hello and welcome to Section 4 of this course. In this section, we're going to be talking about functions, how to create them, how to invoke them, and what they're for. First, we're going to see how to create a simple function, which does not receive any parameters. Then we'll expand that and learn about the many ways that functions can accept parameters and produce resulting values. Finally, we'll learn how to use functions as part of larger expressions, including several ways to send data to the function. Functions in modular programming. We're going to start off in this video by talking about what functions are for, how they help with modularity, and why we care about modularity, as well as seeing the basics of how to create functions. In the next video, we'll learn about how to write functions that are able to receive data from the rest of the program when they start, and return data back to the program when they finish. These capabilities mean that running a function is an operation that can be used in expressions. In the last video, we'll learn about how to run functions, and see some of the interesting and useful variations on that theme that are available. Alright, so what am I talking about when I say modularity? That's just jargon for organization. When we write a program, we can either choose to keep the code organized in a sensible way, or we can just splat it down and hope for the best. For tiny little programs like our examples in this tutorial, it hardly makes a difference. But if we're going to be writing larger programs, we're going to want to keep the parts of our code that do one thing separated from the parts of the code that do something else. Functions help with that. In some ways, a function is a lot like a complete program. It contains statements and expressions, it runs when we tell it to, it works on the data we put into it, and it gives us data back out. So when we build a program out of functions, we are in some sense building it up out of smaller building block programs. One of the big stumbling blocks for larger lengths of code that are not broken up into functions is that one part of the code might change a variable in a way that another part was not written to take into account. Functions help us with this by having what's called a local scope for variables. That means that when we assign a variable in the code of a function, that variable assignment won't affect any of the code elsewhere in the program. It's only for the code in the same function. There are ways to affect variables that are not local, but having a local scope makes functions a lot better at playing together. Another thing that happens with long runs of code is we start seeing the same basic idea pop up more than once. Maybe it's exactly the same code being repeated, or just similar code that only differs in some definable way each time we use it. When we see cases like this, that repeated code should always be turned into a function. Factoring out repetitions like this makes our code easier to read and easier to modify, both of which are very good things. When we define a function, we are creating a new operation for use in the expressions elsewhere in our program. That function is defined as a sequence of statements and expressions, which can and often do invoke yet more functions. The operations given on this slide aren't exactly what the print function does, but it's close enough to give us some idea. So, here, writing print high means the same thing as writing expressions to convert high into a byte string, and then append a new line, and then send it to the standard output stream. Each of those operations, in turn, means the same thing as writing a bunch of lower-level steps would mean, and so on. Here we have created a new function using the def statement. Def is short for define because that's exactly what it does. It defines a function and assigns it a name. We've used several expressions and sub-expressions in the function's code block, including multiple invocations of the print function. But we also have an assignment statement. We assign the value of 2 to the variable called baz, and then use that variable in a few places. One place we tried to use that variable is outside the function's code block, on the line after we invoke the function. So, when we run the program, it will run the code in the function's code block, and then afterward it will run the print statement, and try to print out the value stored in the baz variable. Except that doesn't work. Things proceed just like I said, but when Python tries to find the value of baz, it discovers that there is no such variable, and of course that means that there's an error. This is an example of the local scope I was talking about earlier. The variable baz is local to the code inside the function, and does not even exist as far as the code in the rest of the program is concerned. In this example, we've gone even further and used a variable name inside the function that is also used outside of it. However, the variable inside the function is not actually the same variable as the one outside that has the same name, thanks to the local scope inside of functions. Because of that, assigning a value to the local baz variable has no effect on the baz variable seen by the rest of the program. And so by the time we get to the last print, baz still contains 17. Local scoping also applies between one invocation of a function and the other invocations of the same function, if we choose to run the function more than once. That means that if we store a value in a variable when the function is running, that value will not be stored in that variable the next time we run the function, unless we happen to store the same value again. Local scoping only applies to variable names. Values contained inside of data structures, or other similar objects are not affected, and so we're free to assign a new value to a dictionary key, for example, inside the body of a function. That new value will continue to be assigned to that key even after the function ends. Finally, the code inside of a function is allowed to look up the values of variables that were assigned outside of the function, so long as they do not assign a value to a local variable with the same name. That is, in fact, what we're doing here when we invoke the print function. Print was not defined within this function's scope, but since no value was assigned to that name within the scope either, Python knows to go look for it elsewhere.